Now we're going to combine our rigid motions into what's called compositions of rigid motions. So we're going to do more than one rigid motion to an image. And I know this image is a little bit blurry, but if you look at the picture, we want to know the type of rigid motion that takes place from image 1 to image 2, and then 2 to 3, and then 3 to 4. So we'll take them one at a time. Going from 1 to 2, I know it's blurry, but this point, if you can see, we have a center of rotation, and he's being rotated, well, we could either say clockwise or counterclockwise. If we talk about counterclockwise, he would be going this way. So if I were to describe that, you could actually measure that angle, and that angle, if you measured it, would be 150 degrees. I'll just tell you that. So if I want to describe it, we would say it's a rotation about point A, rotation about A of 150 degrees. So the notation for that is a capital R about point A, comma, of 150 degrees. That's how you would describe the first transformation. Then, if you look, going from 2 to 3, this is a line reflection. My triangle is reflected over line CB. So the notation for that is going to be little r with the line segment. I reflected over BC. And then the third thing we did was a translation. I'm translating going from 3 to 4, and I'm using vector DE to do that. So a translation using vector DE would be capital T, and then I would describe vector DE with the arrow. So when a series of rigid motion takes place with one rigid motion building off another, like we just did, we did the rotation, the reflection, and the translation, this is called a composition or a composite. The symbol used for compositions to represent a composition, which is a combination of rigid motions, we either use a little open circle or we use parentheses. And I'm going to show you that notation both ways. So when performing or writing a composition, here's the big thing. If you are writing this, you've got to work from right to left, which can be a bit confusing, but we want to think about inside and out. So if I'm writing this composition, the last rigid motion we did was the translation. So that's what I'm going to write down first, because I've got to work from the inside out. So my translation of DE, there's my translation vector. I applied that. That was the last thing I did. So before I did that, I had a reflection over line BC. And then the first thing I did was a rotation about point A of 150 degrees. To all of that was applied to triangle PQR. So there's that parentheses, and the one for the rotation, and the one for the reflection. Now think about your order of operations. When we do order of operations, we always work from the inside out for parentheses. So this is why we have to write it backwards, because the first thing we do is rotate about point A 150. Then the next thing we do is the reflection of all that. And then finally we translate our answer to all of this. That's why we have to go backwards. Now instead of using parentheses, I could use a little open circle, but the order is the same. It's a translation. That's the last thing we did. And then we have an open circle. Before the translation, we did the reflection over line, well, BC. I'll be consistent here. Okay, so try this again. We had the last thing we did was the translation of vector DE, and before that we did a reflection over line BC, and then the first item again was the rotation about point A of 150 degrees, and then I have my parentheses because I'm applying all of that to triangle PQR. So the red and the blue statements say the same thing. I've just replaced parentheses with the open circle. So here's how I'm going to apply this to an image. I have a pentagon. I've got two lines of symmetry. I have labels A through E. Here I have a composite function, a composition of transformations, and I want to know what happens to E after I do these two things. So again, we're going to work right to left. The first thing that's happening is I'm reflecting E over line M. So I'm going to separate that out. This is the first thing that's happening. I want to know what letter would he be at if I reflected point E over M. So here's E, here's line M. If I reflect him, he's going to be up at A. So that's how I process that. Now, that's the same as, that's my first answer. So now I'm going to apply this answer, which is A, to this line of reflection. So here's the second part of that. Now I'm going to reflect point A over line L and get my final answer. Point A over line L. This is line L, so if I reflect him over here, he's going to be C. So the answer to that composite is C. All of this yields C in the end. So for the second one, I have line BA, or line segment BA. I'm going to reflect that over L, and then that answer is going to be reflected over M. So here's my original segment, BA. If I reflect him over L, he ends up being BC. So now, so let me separate this out. R, if I reflect BA over L, I get BC. And the order is important. So B is on the line of reflection. So BA turns into BC because A maps to C, and that's an important little thing. So now I'm going to reflect BC. Oops, I'm going to reflect BC over line M. And my final answer is going to be, let's see, BC when I reflect over M. That means C is going to stay there, and B is going to reflect down to D. So he's going to end up being BC, ends up being DC. Again, you gotta, the order is important, so B maps to D, so D has to be first. So my answer for the second one here is DC. The third one, I'm going to rotate B 72 degrees. So here's angle B. When I rotate him 72 degrees in the positive direction, he's going to end up at A. So that's my first answer. When I rotate 72 degrees, point B, he ends up at A. So that means I'm going to reflect A over line M. Reflect an A over line M means he ends up at E. So my final answer is E. We're going to do more of those in class so you kind of get the hang of it. Again, it's important you have to work right to left, and you have to be careful when you're dealing with segments that you have to be careful with the order of the letters, and you have to follow what's being mapped to what. So now we're going to do this on a coordinate grid. The coordinates of triangle ABC are shown, and I've already plotted the points and drew the triangle there. We're going to graph and state the coordinates of double prime, A double prime, B double prime, C double prime, after the composition of this right here. So again, we have to work right to left. The first thing we're doing is the translation and then the reflection. So what I'm going to do is I'm going to write my new coordinates down for the translation first. I'm translating 2, -3. So for point A, I'm going to write them down here. Point A, if I add 2 to the x and -3 to the y, I end up being at 0, -1. B prime is 5 and 2, and C prime is 6, -1. That's what happens when I translate this triangle to 2 points and down 3. So let me plot that new intermediate step. 1, 2, 1, 2, 3 is here. I'm only going to plot the points, so I'm not going to draw the triangle. There, 1, 2, 1, 2, 3. So those are the locations of the intermediate steps. But now I want to get the final points. When you do a composite, we really only care about the initial and the final. We don't really care about the intermediate steps. So now I am going to reflect over the y-axis. So I'm going to take these new points and apply my rule, my reflection over the y-axis. And when we do that, we change the x, which means a double prime is 0, negative 1. B double prime is going to be 5, reflect over the y, 0, negative 1, and, nope, not 0, negative 1. I'm getting myself confused because I was looking at the other thing. Do this again. Reflecting over the y, you negate the x. So, well, that's why he's 0, negative 1, because you don't change the x. For B, he's negative 5, 2. And for C double prime, he's negative 6, negative 1. So here's my final triangle. 0, negative 1. A double prime is in the same spot as A prime. B double prime is negative 5, 2. So he's up here. There's B double prime. And C double prime is negative 6, negative 1. And there he is. Now we have a special name for this. When it's a translation and a reflection, it's called a glide reflection, because what happened here, if you look at it, he flipped over the y-axis and then he scooted down. So this can be a flip, scoot, and we could keep doing this, a flip, scoot, a flip, scoot. And when that happens, it's called a glide reflection. So we're going to finish this lesson by doing the first example here. We'll do the rest in class. Using the diagrams, write the rule of the composition. So if I look at this guy, I have D, E, F, and I have D prime, E prime, F prime. That tells me D, E, F is my starting point. I start here, I finish here. The next thing I can look at is the orientation of the letters. D, E, F is going around clockwise, but my prime is going around counterclockwise, which tells me I have a line reflection involved. So let's take care of that first. Let's reflect this guy, and there's a lot of different answers you can use. I'm going to reflect him over something easy like the line, the x-axis. So that's what I'm going to do. My first guy is going to be a reflection over the x-axis of triangle DEF. And I'm going to dot in what that looks like, because we have to go from there to figure out the next step. If I reflect him, he's going to be down here, so this is kind of what he looks like. Okay. All right. To get to the next guy, I'm basically going to translate. There's my translation vector. So I could just call that, well, since I don't have an intermediate step, I'm going to count and use the numbers for the translation. So I'm going to translate. I'm going to put my little symbol there, and it looks like I'm going to go negative 1, 2, 3, 4, 5, 6, negative 6 in the x direction, and 1, 2, 3 in the y direction. And that takes care of your composition. Remember, we start to the right, we go right to left to start at the beginning, and then do the last term. The rest we're going to practice in class. You can take a little bit and see if you can figure it out yourselves, but we will do those together in class.